Yeah, I think we can start. So thank you everyone for joining in, and we are very delighted. We have Ajay Divakaran from SRI International today with us. He will give a presentation, and later today he has agreed to give like a career journey talk to inspire the RU students, and then after that we will have one meetings. And so after the meeting, after the talk, like if you want to meet him, just let me know. I mean, we already have like all the slots full, maybe, but later, like if he has time, we can arrange a one-on-one meeting. Okay. So Ajay Divakaran, he's like a technical director of the Vision and Learning Lab at SRI International, and I think Ajay, he did his PhD from Rensselaer Polytechnic Institute, and so he works in multimodal data and understanding human behavior, event detection, tracking all those kind of vision problems. And so one of the work for which he is very well known is the playback enabled DVR, which was developed when he was working with Mitsubishi. That was, I think, in late 1990s. So yeah, I think without any delay, so please welcome Ajay. And so Ajay, the floor is yours. Thank you.
Thank you, Yogesh, for that kind introduction. Today, I'll talk to you about using hierarchies of skills to achieve and assess automatic multimodal comprehension. I'll take a little time to describe SRI International to you. So we are an independent non-profit research institute. We were founded originally by Stanford University in 1946, but then sometime in the 70s we were divested, so we are independent of them. We have so our business model is that of contract research. We do contract research both for government and commercial clients, and you can see we have all these locations and labs, and about half of our employees have at least a master's or higher, right? And what we do is develop prototypes. So we are somewhere between industry and academia, where we also do academic style research, university style research, but we also build prototypes. So there are all the innovations that SRI is known for. The most famous one is Siri on the iPhone that came out of SRI. It was spun off as a company, and then so this is just to give you an idea of all the fields that SRI covers, systems, education, information and computing sciences. So we are in the information and computing sciences division, and specifically at the Center for Vision Technologies. But you see that we also have a biosciences division. So it's a sort of a, the variety of interests is quite wide. And within the Center for Vision Technologies, I lead the Vision and Learning Group, as Yogesh just said, and we cover all these aspects of vision and learning. As you can see, I won't, belabor you with all this. So having told you about SRI, let me talk to you now about multimodal comprehension. How do you define multimodal comprehension? How do you evaluate multimodal comprehension? And how do you realize multimodal comprehension? So this is the outline of the talk, which I have already gone through, as you saw. Now, let's motivate this work. So as many of you probably already know, visual question answering is an active area of research in the field. And the first time I saw visual question answering, I was actually quite intrigued, because what you need to understand from a historical point of view is that before deep learning came along, vision researchers used to be very thrilled if they could, say, detect a truck with some very high level of accuracy. That was considered a very, very big accomplishment. And today we are at a point where you can ask this kind of question saying, is the tray on top of the table black or light brown? And it comes back and says, yes, it's light brown. It's giving you a pretty good answer to the question, right? Now, it's out there and all sorts of tasks. So, either you subdivide the questions into different categories, or you can have another task with a different input, and you test for consistency, you test for common sense. And, there was this nice work that came out called the GQA, or graphical question answer, and so forth. So there's a whole variety of visual question answering task that is out there. Now, and I will tell you a little bit about this GQA, or graph question answering. That what happens here is that the idea is for the system to learn what the structure of the question is that is being asked, rather than the specific question, right? And because they are able to organize the questions in these kinds of graphs, they are able to systematically paraphrase these questions in all kinds of ways. So the same question can now be asked some 10 or 20 different ways, as a result of which the number of questions grows. And so you can test for consistency, right? You can say, well, I asked this question, say question A, and I asked it some 10 different ways. Did you give me the same answer every time, and so forth? So there is a whole lot of interesting stuff that goes on over here. So now the question is visual question answering the same as visual understanding? That's a very important question to ask, right? So the first time I looked at visual question answering, what struck me was that there is no notion of the relative difficulty of questions. Whenever you are quizzed, you are in a university setting. Whenever you are quizzed, there's a notion of a certain question having on a test having more points because it is considered a more difficult question or an advanced question, right? Now, in these visual question or even language question answering data sets, there is no notion of difficulty of questions. All the questions are about, they are graded equally, regardless of how difficult they may be. So that struck me immediately when I got into this area, saying this doesn't make sense. Now, this GQA, this graph stuff that I described to you, it says, okay, we will guard against educated guesses and gaming. And I'll come to this a little later, where what happens is that these machine learning systems have superhuman capabilities, as you know. They can read thousands of pages in seconds. And therefore, the assumptions that a typical test has with human beings, right, just break down when it comes to computers. So when you give a human being 100 question, multiple choice question test, by the time the human has got to question number 45, they have forgotten what question number 12 was. But if you make a computer do it, it actually knows. And it will be able to extract all kinds of patterns and basically hack the answers, right? So VQA, in my view, is not grounded in a science-based definition of comprehension. So now what does that mean, right? So what happened with me was, I'll digress a little bit here, go off on a small tangent. So when our daughter went off to college, I found these books sitting in the closet on English reading comprehension that I had bought for her. And, neither of us had cracked those books. So they're just sitting there in mint condition. And I found them there. So I said, fine, it's too late, let's read them. And when I read them, I was actually very surprised to see that elementary school teachers, in fact, have a very computational view to story representation. And we'll come to that in a moment. So I want to say one thing up front, okay? When I say that I was inspired by comprehension in an elementary school classroom, I'm not saying that automatic multimodal comprehension needs to work just the way it works, just the way a human being does it. I'm not saying that at all. All I'm saying is that the anthropomorphic approach gives us some kind of understanding of how to come up with at least some evaluation criteria to find out whether comprehension has actually happened or not. So what we are interested in is laying out a graded approach, consider the computational approach and say, okay, let's compare the computer. Is it able to operate at the level of a student in the first grade in elementary school, right? Now, there is a very, very big caution here. So the big caution here is that all these teaching strategies in the classroom count on both the teacher and the students being human, okay? So state of the art competition is left in the dust by about second grade. The kinds of imagination that children at that age have and their ability to connect the dots far exceeds whatever competition can do. So we are interested anyway in the K through 5 classroom approaches to comprehension, and these were two books I saw. Strategies is Work and Reading with Meaning, written by Debbie Miller, who is an actual elementary school teacher, in fact. And this is the computational thing I was telling you about. So what these folks do is actually encourage children to come up with some kind of a computational representation like this of a story, right? What are the key concepts? And then the teachers are also trying to find out, okay, what is the learner profile? How much of cooperation are they showing and so forth. So what you are seeing is a combined model of both the story and the learner, right? And so this is fascinating that they are not just saying that, oh, it's an art and it can't be taught, etc. They seem to actually have a system around how they are teaching in the elementary school classroom. Now, all this feeds into Bloom's taxonomy of learning objectives, right? So this is something that has been established in the educational psychology literature or applied psychology literature. This is a 2-author paper. I think Bloom is the first author. And this is based on many years of research and collecting opinions of people. So I wouldn't say that there has been any research directly on Bloom's taxonomy, but it is more an aggregation of many papers showing these kinds of results. So what does it say basically? It says that human skills can be organized in this kind of hierarchy. So the hierarchy is at the bottom, it is just remember, as in sheer recall, right? Do I know that Orlando is in Florida or not? That is sheer recall, right? But understand, apply, analyze, evaluate, and then finally create, right? So this is very intuitively satisfying. You can see that there is a clear stepwise progression in the skills. And now look at the verbs on the right. So with remember, you have verbs that are completely related to recall, like define, duplicate, list, memorize, right? But with understand, you're already up there. You say classify, describe, discuss, explain, identify, etc., right? And apply gets even more sophisticated. It says, can I use this information in a new situation, right? So if somebody teaches me how to make pancakes, then if somebody asks me to make crepes, can I make them, right? This kind of thing. And then analyze is at yet another higher level. And so I won't belabor this point. All I want to say is there's a very natural question. Where does the current state of the art lie in this hierarchy, right? And the answer is that pretty much somewhere in the gray zone between understand and remember, right? There are claims made about transfer learning and all that, but let's just be very honest. No, I mean, in terms of achieving these, in terms of scaling this Bloom's taxonomy, pretty much the state of the art is somewhere in this gray zone. Now, there is some work that has been proposed that says that, we can create, so all these generative models you have heard of, they talk about creation. But the question is, how smart is that creation is a good question one should be asking. It is not very clear. So let's go to, so this was work we published at WACV, right? And the idea was, how do you benchmark multimodal machine comprehension, right? So what was the problem here? The problem was
Our
that,
focus is on procedural multimodal.
sorry. I am realizing that there is some audio which I should remove. But anyway, so the idea is that you have a data set that is basically giving you recipes as well as pictures, right? So there are steps, as you can see, with ingredients and so forth. Prep, then cook, right? And it goes right down to serve, right? And it's also giving you pictures that go with that. And now you are asked questions like, fill in the blank image, right? Fill in the missing blank, or what is the incoherent image, and what is the correctly ordered image, and so forth, right? Now, so it looks like to answer these questions, you would need to understand. That's what it looks like, right? Now,
several challenges exist.
So now, so what are challenges? So the challenge basically is that these data sets have a lot of bias. So what do you mean by the bias? So this is what I was telling you about earlier, that these computers approach these data sets in a way that is very different from how human beings would approach these things. So what they do, for example, is that they figure out what the structure of the answers typically is. So instead of understanding the question, they just pick up on what the structure is and they start answering the questions, right? So there are, so let's look at what kinds of biases there are, right? So if there is overlap between questions, right? If the answer to a question is actually in another question, a human being will not be able to make that connection if there are 40 questions down, but a computer can, right? The other is that the correct choice is very close to the answer, but the incorrect choices are very far. So all it does is just hacks it. And in fact, recently I saw another very interesting example of bias where it figured out that the correct answer tends to be the longest. So it just picks out the longest answer and says that's the correct answer, right? That was in another setting that it logged onto this kind of interesting bias. And then look, so the bias too is that the incorrect choices are far away from the correct choices. So which means that you just find the odd man out, right? You just say, what is the odd man out in these four? And you don't even need to read the question. So in fact, what Pritish and Karan, my co-authors, did was that they actually ran they trained a classifier called a hasty reader, which only looked at the answers, right? It didn't even look at the questions. And just by reading these questions, the answers, it figured out what pattern there were, and it did very nicely on the challenge task, right? So
we identify 3 key biases. Will it?
So now we came up with these so-called 3 control knobs. So in short, what we are doing is, since we identified these biases, we come up with a notion of what I call a data set cloud rather than just a single data set. So what you do is you take a single data set, but you use these knobs. So what you do is that you say, okay, the correct choice is an odd man out. So can I try to make it not be the odd man out? So I add some kind of noise there to make sure that the other answers come closer to the correct choice, right? And they are not all clumped together. The same way, what I do is I also say, I want to make the incorrect choices closer to the question. than they are currently, so that it doesn't hack it by just saying that, this is my correct answer, right? So, and then another thing I have to do also is to find out whether there is so much overlap between the questions that the answer gets revealed. So can I fuzz that out also, right? So I have 3 knobs. So which means what I should be doing is take the data set and create these fuzzed out versions of the data set. So now I have a data set cloud basically. I have a whole ensemble of data sets that have come from the core data set. Now what I do is I run my test and I say my baseline should do a good job, right? With this kind of a thing where I've actually where I have removed the bias. And what we have done is we have come up with our own technique also, where we train, essentially you can see this is a transformer based model where we are training it with so-called context, which is all the steps that you saw. We also train it with question answer pairs, right? And so that is our model that we use to propose to implement the previous model, and then we propose a hierarchical transformer based reasoning network, which I just showed you, right? This is the transformer based network that I just talked to you about.
Here we demonstrate the efficacy.
And now I wanted to talk to you about how see, when we remove the bias, it becomes much harder to improve upon the baseline. But we are able to get a pretty good improvement with our proposed model, but after removing the bias, right? And that's what I want you to understand here, that now, the hasty student and the impatient reader are no longer able to get the fantastic performance that they were able to get when the data set was full of biases that I described to you earlier. So this is an important pitfall. This is very important to understand. This is part 1 of my presentation, which basically says that is my system actually understanding, or is my system just hacking the question answer structure and coming up with answers to questions, right? So, so that is kind of, that is part 1.
In the top plot.
And
we use potato skin.
And then what I wanted to show you also was that in some cases we succeed and in some cases we fail, right? And so let's look at the one where we failed actually, right? So we said, which should be the, which one should we fill in over here? And it turns out that even a human being has a hard time answering that kind of a thing, right? Likewise, the medium also is not easy to answer. But when you look at the original, you could just hack it by just looking at the thing and saying that, yes, it's quite easy, what I'm going to pull, right? Because the one you can see is much different from the other 3 alternatives. So that should give you an idea of what we are after.
For more details.
So if you have any questions at this stage, I'd be happy to take questions. Otherwise, I'll move to the next part. So any questions? Okay. So let's move to the next part then, which is how do we, can we use Bloom's taxonomy to actually answer questions, right? Because that's a question that one could ask. They say, you have told me that there is a hierarchy of skills, but how is this hierarchy of skills useful? Can I apply it in some manner? Is a very good question to ask. The answer turns out to be yes. Now, You might have heard of these large models, right? Large models like GPT-3, and most recently, of course, this model from Google called Imagen. So you see that many years ago, there was something called ELIZA, right? Just a second, let me just check something because my internet connection at the office can be flaky. Give me a second. Okay. Okay, my hope is that it will so now you look at the language model, so it has it has 185 billion parameters that have been trained on some terabytes of text, right? So the scope of the language models has gone up this much. Now what you do is you give it a question. You say, if I mix cranberry juice and grape juice, what happens? So, these models have been shown to succeed very well, but then there is a whole, there is a class of dissenters who come up with these counter examples. So this is a counter example from them. If you ask a human being, what will, can I drink a mixture of cranberry juice and apple and grape juice? The human being will say, yeah, go ahead, right? No problem. But you ask GPT-3 and it tells you that you will die if you drink this mixture, right? So now what went wrong here is the question, right? And I have a guess, I could be wrong about this, but my guess is that somehow, because GPT-3 has been trained with text from all over the place, right? So there is no control, there is no curation, it's completely unsupervised training. So GPT-3, I think, saw somewhere that mixing drinks is a bad idea. Okay. And it has that kind of fixed notion somehow. And so when this kind of question came along, it's saying, okay, mixing drinks bad, not mixing drinks good. And so it said that you're going to die, right? So now the question here is, how can I make sure that GPT-3 does not make a mistake like this, right? How can I ensure that it doesn't totally mess up? So now there was some prior work done on self-talk done by Vereth Schwartz at the Allen Institute, where what she was doing was she was saying, instead of only asking a question directly, let me ask it some clarifying questions, right? So I can ask clarifying questions like, is grape juice poisonous? Is cranberry juice poisonous, right? I can ask these so-called clarifying questions and then get those answers, and then I supply everything, right? And then I see whether the answer changes or not, right? And it turns out that even with that kind of a system, when you say, what happens if you sniff a mixture, it says you feel woozy because it still has this fixed notion that mixtures are bad, right? And so it is still telling you that if you drink it, you are now dead, okay? So now what we do is we ask it, but now there is a bit of a clue here as to how we could get out of this problem. So maybe if we change the clarification question, we have a better shot at answering the question, right? So what we do is we ask it the question, is the cranberry grape mixture poisonous? And it says, no, it is not poisonous. Now we send the original question and this question answer pair that we got from it. And what GPT-3 says is, go ahead, drink it. This mixture will not kill you. So now, so what does this mean? This basically means that I can get GPT-3 to give better answers if I have a systematic way of generating the clarification questions, right? So what happened was that we whereas Schwartz developed these clarification questions before this terminology called prompt engineering developed. So today, these kinds of things are called prompts, right? And when I say today, in machine learning, it looks like every 3 months there is something completely new coming along. So whereas Schwartz's work is not that old really, it's only about a year and a half old, but machine learning years have become like dog years now. So 1 year of machine learning is equivalent to some 5 years in other field. So anyhow, the idea is at least we now have some concrete task here, right? The concrete task is, can I come up with a systematic way to generate clarification questions that will help GPT-3 give me correct answers, right? Okay. So the key is that there is no learning involved. So in our method, we are not interested in trying to retrain GPT-3, and you can understand why. I just told you that GPT-3 has billions of parameters. Why would we want to retrain GPT-3, right? I mean, that's just too much effort. So instead, can we stay at an exploitation layer that is above GPT-3 and get it to work, right? So now I told you about Bloom's taxonomy already, but I'm reviewing it for this reason. So what we essentially say is, this is our hypothesis, okay? Our hypothesis is that I look at a question and I say, what level is the question at in Bloom's taxonomy, right? So is the question making me apply it to a new situation? If yes, it must be at the apply level, so which is level 3, right? So my apologies, we are not, starting counting from 0, we are counting from 1. But and likewise, if the question had something about, say, explain, then we would said, okay, it's at level 2. So our hypothesis is this. If you are at level n of Bloom's taxonomy, I should generate clarifying questions and answers at level n minus 1. So we call this proximal context. This is the most relevant context. If we generate those questions will be the most helpful. And so the thing is that actually, in a sense, is dependent on there being a hierarchy. If that kind of thing did not work, you know that there is no hierarchy in fact, right? So in short, if I am at level 2, I should have questions, supporting question at level 1. If I have a question that is at level 3, I should have created clarifying questions at level 2, right? That is our operating hypothesis, and that's what we define as proximal context, right? And the good thing is that proximal context is a task agnostic notion. It is not task dependent, right? All I'm saying is, I want to go down one level. So what did I do with that other question? What happens if I mix grape juice and cranberry juice? I just asked a factual question. I just said, is grape juice poisonous? So I can have a question template that I instantiate for the task at hand, but the question template itself is task agnostic, right? And so now what we do is we consider a new prompt, right, that I mentioned to you. We say, is the cranberry grape mixture poisonous? And the answer comes back. So GPT-3 is smart enough to know that cranberry juice is not poisonous. So then we say, is cranberry juice with grape juice poisonous? And if it says no, then you say, okay, this is what I have found out from you. Now, do you still maintain? Right? So this is almost like I'm in a Perry Mason show or something. And I say, would you still stick to your prior testimony that if I drink grape juice and cranberry juice, I'm going to die? And the answer is no, right? And so this is what is This is our basic strategy, right? That it is, now what we do is we evaluate this on various question answering in some way or the other. So there is this choice of plausible alternatives, COPA, common sense QA, Vino Grandi, and social interaction. I'll give you a minute to sort of read through these because I don't want to read these out to you. That so you get the general picture, right? That each of these data sets tackles a certain aspect of common sense, right? And now you want to know if this will answer these kinds of questions correctly or not, right? Now, the levels are important to note. So this kind of a question, the man broke his toe, what was the cause? That is level 3. Where on a river can you hold a cup upright to catch water on a sunny day? That's also level 3. But this is level 2 because Katrina had the financial means to afford a new car where Monica did not. So this is not as, this is like an understanding question. This is not an application question, right? And likewise this one, right? So now what we do is that based on the level I was telling you, we have a fixed question template. We basically say, we have this question prefixes. What is the definition of, what is the main purpose, what is the main function, what are the properties? So it's almost like a 20 questions approach, right? You have a very fixed approach. That is not changing because the question changed, right? So this is fixed, but you are instantiating now the question based on the task at hand. And now it turns out when we do that, we actually beat the state of the art, right? So we are actually able to improve by generating these kinds of clarification questions. We get the best results when we use what we term proximal context, which means if you add clarifying questions that are at just one level below, that is when you get the best improvement, right? And you are seeing that in these graphs, for example, right? That when I use for all level 3 questions, if I use level 2 clarifying questions, I get the best results, right? So, and it's kind of interesting that even when you use all clarifying questions, you are not able to exceed what you are able to do with the proximal context. So this is very interesting actually, and this actually is applicable in your daily life also. When you're teaching someone something, this is telling you something, right? So proximal context is better than lower levels of context is what we find across all these data sets, right? And it is as good or better than the higher levels of context. So even if I pull context from something that requires more skill, right? It doesn't particularly help me. And the proximal context is as good as the language model's choice. So now there are some qualitative results here. In the interest of time, I will sort of skip ahead, but you see now, the question is, the secretary put the collar on hold. And so the question is, what was the effect, right? And so Distill GPT-2 says, what is the main purpose of this? The main purpose of this is to prevent any further incidents from happening. But the point is, the correct answer is the caller waited online. Whereas GPT Neo gives a clarification answer that kind of gives a question answer pair that makes more sense, right? The main function of secretary is to keep the phone call short and sweet. One may argue over this, but at least it's more reasonable than what GPT-2 seems to be saying. So now I should explain something. GPT-2 is a smaller model and GPT-Neo is a larger model. So we are trying this Bloom's taxonomy approach with a small model and with a larger model, right? And we ran another experiment also, which was that we said that so far what the model was doing was it was eating its own dog food, okay? So it generated the clarifying questions and then it used those to help it answer the main question, right? Now, an obvious question to ask is, suppose I have generated the questions with GPT-2, but I give them to GPT-3. So I generate the questions with a small model, but I do the question answering part with the larger model. What happens? So what we find basically is that the interpretation quality matters more than clarification quality. So it turns out that but there are some very interesting things that come out. So the smaller model is not smart enough to come up with good clarifying questions. But if it is given high quality clarifying questions, it is able to improve its performance. So this is very interesting, right? There is this kind of what you would think of as emergence, right? That these models seem to actually, as they grow bigger and bigger, they seem to actually become more mature, as it were, in the way in which they are answering the questions. As in the clarifying questions make more sense. And so what we have done here is, in this part of the work, we have defined comprehension using Bloom's taxonomy, and then we have realized Bloom's taxonomy through this concept of proximal context. And we have used the proximal context to improve the language model performance, as you saw, right? And the advantage is that we are not touching the large model at all. We are just using the large model as is, which means that the training burden is low and it is task agnostic. So we are not, we are not coming up with a new strategy every time a new question comes along. The overall strategy remains the same, right? And so in future, what we want to do is improve the clarifying question generation, and we want to have more diverse data sets, because it turns out that the data sets actually are more or less stop at level 3 of Bloom's taxonomy, and then test other large models that might have come around. So this concludes part 2 of my talk. Again, I'm happy to take questions if you have questions now, or what I'll do is, given the short time we have left, I will give you a quick view of part 3. So any questions or comments?
Yeah, questions maybe we can take at the end if there's
Okay,
any.
so let's move along then. And so this is work we are doing jointly with the Rochester Institute of Technology, with Robik Shrestha, who is a grad student of Professor Chris Canans, right? And we are trying to create a new data set. So this one I'll kind of rush through, because we're not, I took, I think, more time than I had planned for the other two parts. But the background is very similar, really. I mean, the idea is to get a new data set now that truly probes. So what would that mean? I showed you Bloom's taxonomy. So what you want actually is a data set that should have questions at all those levels of sophistication, right? All those skills should get tested. And so what we are doing is we are collecting data, and I'll skip over all these other things because I already went through these things, right? With you. So I can skip through all of these things and go directly to the data set. And so we are interested in a data set that gives rise to new tasks and new metrics, right? And what we have done is, this was actually my favorite part. I looked for content under the Creative Commons license, and I was delighted to find that, which has a whole bunch of very nice stories that are available under a Creative Commons license. Likewise, I found another story set from Book Dash, which is out of Africa, and it has all kinds of books there, and again, under the Creative Commons license, which is a big relief. And another very good thing about this, and I would, anytime you want a change of pace, go check out these stories. They're pretty good, actually. I mean, I enjoyed reading them. And these stories are sometimes silent, as in they just have pictures. There is no text there at all also, which again is good. So, there are all kinds of artistic styles: realistic, cartoonish, distorted, abstract. And see, there are all kinds of examples of this. And so what we want to do is, we want to take the idea of the scene graph that I showed you earlier and extend it to story graphs, right? So now, instead of just talking about a visual scene saying, there's a river, and, along the river, there are these houses, and behind the houses, there are these hills, etc., right? Instead of doing that, you actually now have a story, right? Because the scene graphs and patterns are mostly suited for questions that are at the bottom of Bloom's taxonomy. They are only about giving you recall type question. Is there a river? Is there a, right? But the question you might ask is, do you think I could sail a paper boat on that river? And that's at a much higher level of understanding. So what we are interested in is coming up with story graphs, and story graphs at every level of Bloom's taxonomy. So in our new data set, that's what we are doing. We have come up with these question stems that we are instantiating at each of the Bloom's taxonomy levels, right? So we have Robik Shrestha has come up with this fantastic interface. If any of you are interested, let me know. You can try this out and even, have some fun and generate some data. And so, we also have them assess the quality of the questions, right? Does the question make sense? Is it relevant to the story? Etc., etc., right? To test what level the question belongs to, right? Because we are dealing with Amazon Mechanical Turkers, so which means we can't assure the quality of the questions. So anyhow, this is the collection pipeline. I'll jump over this. I mean, you get the basic idea. There is a lot of details, but now, this is where we run into some problems, right? There are ambiguities in the original Bloom's taxonomy. How do you accurately present Bloom's taxonomy in the user interface? How do you get general Turkers to understand what only typically experts would understand, right? Because this takes this is not like annotating whether there's a dog or a cat in a picture. This is a much more sophisticated annotation task. So the new tasks and metrics are, number one hypothesis is that questions from the higher Bloom's level or higher levels of the taxonomy are more challenging, right? Second hypothesis is that if a machine succeeds at difficult questions, it should not fail on the easy ones. So this is like show your work that you might remember from elementary school, right? Your teacher will say, show me how you got this answer. So don't just give the answer, because then I don't know how you came up with the answer, right? And that lower level skills are needed to answer higher level questions. So which means that, are you consistent over all the versions of the question? So I ask you a higher level question saying, can I land can I land a helicopter on the lawn of the White House? And the answer is no, yes. But suppose I now add another question saying, where is the White House? And if that changes your answer, that's a sign that you're not really understood, right? And paraphrasing should not affect the machine. So which means that if I ask the same question some 10 different ways, I should still be answering all the questions correctly. So this means that instead of just having question answering performance in terms of just average accuracy or whatever, you now actually have a different set of metrics that measure multiple kinds of consistencies, right? And we are basically asserting that those kinds of consistencies, according to these hypotheses, will establish whether comprehension has actually happened or not, right? And so I would say this. And so there are some challenges and so forth. So what I would say is that what these kinds of tests will establish for sure is whether comprehension failed to occur. Did comprehension actually occur is a much harder question, because whatever I have presented to you today is more of an operational definition of comprehension. It is not some definition of comprehension for all times to come, right? It is based on what we are able to do today, right? So in short, what I did today was I presented to you the notion of multimodal comprehension, its roots in elementary school teaching, then showed you how biases in data sets can allow you to get very high scores without understanding anything, and how to remove those kinds of biases. Then I talked to you about how you could use a skill taxonomy like Bloom's taxonomy to actually improve your question answering performance. And finally, I described the creation of a new data set which comes up with new metrics that establish whether comprehension has occurred or not. So that concludes my presentation. Thank you for being a very patient audience, and I'll be very happy to take any questions.
Okay, thank you very much, Ajay. Thank you for the wonderful talk. So quite different from like what we see these days, like people just training on large data and chasing after the performance, right? But this is like totally different take, like how we can bring it this learning more close to like how as a human we actually do inference and all that. So yeah, I have a question before like
Sure.
we jump to the audience. So you were talking about that prompt question, right, where you analyze like if it's like the proximity of that label actually depends in that Bloom's taxonomy, right? For example,
Yeah.
if it's level 3, so level 2 question will be like the most helpful. So I have a question there, like, so level 2 is fine, but if that network is not able to solve like level 3 problem, and you gave a prompt from level, let's say 4, the level 1 above, right? So from what I understand, then it should not be also able to solve that question at level 4. So how should that help in like the overall reasoning? I mean, ideally it should not help at all, right? Because
Right. So it's an interesting point you bring up. And so the only way I can answer that question is, you see, let's go back to Bloom's taxonomy. So Bloom's taxonomy is based on how humans learn, right? So which means we have come up with a heuristic based on how humans learn. So what this is showing is that maybe GPT-3 is not learning the way humans learn. It is somehow finding signal in that level 4. A human being would not find signal in level 4 if they are incapable of operating at level 3, right?
Mm.
But this is somehow finding it. So what does that mean? That is actually an open question. Does it mean that there is something in the data set itself? right, that needs to be addressed is the way the question is being framed. Is it somehow giving away some signal, right? So those are the kind of questions that are still, out there, definitely.
Okay, yeah, great. That's great. Thank you.
That's a very good question. Any other questions?
I have a question about eliminating the bias.
Yes.
So you mentioned using knobs to introduce noise to help with eliminating different biases that you noticed. How do you determine how much to adjust those in order to, like, do you just adjust them and randomly or and see what it does?
So no, that's a very good question. Thank you. So one common way of solving these kinds of problem is to have a diameter based approach, right? So what you do is you say, because you can map them onto some embedding, and you just say what is the distance between these, right? You take a few and get actually some numbers, and then use those numbers to come up with some reduction factors, right? So what you do is, suppose to throw out some random numbers, all right? I mean, not based on what we have exactly seen in the, suppose the three choices are 10 units away, and this one is 1 unit away from the correct answer, right? You should add something to those incorrect choices, so at least they come within shouting distance. They should now come to at least 2. They should not be at 10. If they are at 10, then it can very easily hack that, right? It can just say that these things in the embedding space are too far away, so they can't be the correct answer. So basically, we are using the embedding spaces to give us that normalization and scaling, right? From which we are able to figure out how to get these things closer or further as the need may be. Does that answer your question?
Yes, I understand that. Yeah, you're using metrics, but I kind of, I guess, how do you determine, I guess, when you initially start then, because you would just be, it would sort of be arbitrary, no, like initially, and then you would have to, I mean, using.
No. Let me try to respond. I think I know where you're going with this. Sorry to interrupt you, but let me see if this helps, right? So these are pre-existing question answer data sets. So to some extent, the pre-existing question answer data sets are establishing the diameter, if you will, right? So I start with the pre-existing question answer data set, and I get an idea of the distances between these, right? I get some kind of normalization or some kind of idea of the scale of the distance by just looking at all the existing question answer pairs that I have. And I use those. So if you are saying, isn't the design of the question answer data set arbitrary? Yes, it is. Whoever came up with it, right? But it gives us a starting point. And then from there, now what we have to do is somehow modify those alternatives in a way that reduces that distance, right? And we have the ground truth. We know what the correct answers are. So it's not like we don't know. If we didn't know, then it would truly become a horrible mess. But in this case, we know what the correct answer is. So we can sort of use that as an anchor and basically say that, look, I should not be, I should be around the same distance as the correct answer is from the question, right? So it is arbitrary only to the extent that the original question answer set was arbitrary. I don't know. Does that address what you are asking?
Yeah.
Any other questions?
Thank you.
Yeah, no, that was a nice, thank you. That's, I wanted to make one point. So people talk, bias has become this kind of political hot potato. People talk about bias only in terms of, certain vulnerable sections being ill-treated by the kinds of data sets you have collected. But I just wanted to make the point that bias is a much wider term than that. So, bias crops up in these ways also, where, like I told you, it figures out that correct answers tend to be twice as long. So it just picks those and it gets very good, performance, right? So identifying the biases and then undoing them, the worst thing about these things, which is true about all the political ones also, is not just that they exist, but that they kind of hide in plain sight. So they operate in such a way that sometimes you don't even know that there is such a bias until you actually do something, right? That's the insidious nature of these kinds of models. So I reviewed a paper which showed that this particular model thought all table tennis players were Asian because that's the kind of imagery it had. All the imagery it had Asian table tennis players. And it thought that all table tennis players were Asian. And you keep probing it and it keeps coming back and telling you that, right? And that's actually because that's something that won't even occur to you to ask, right? But the thing thinks that. So that leaves you with this uneasy feeling of what the heck else does it now believe that you don't know at all that it actually believes, right? So lately we have actually been, I have not described that work here, but we are currently working on ferreting out the beliefs of these models. What are some underlying predicates, So for example, if it thinks that all people of Indian origin are bad at math, let's probe that and find out that that's what it actually, somehow that got coded in this thing. So that's a topic for another time, but I thought I would mention that since, these are all related topics.
Yeah, since we are already like out of time, any last question if you have, otherwise we can just move on to the next session. Okay, all right, so let's thank the speaker. I know we are not in person, but still it was a great talk. Thank you very much, Ajay.
Thank you very much.
Thank you all for attending.